different from anything humanity has ever embarked on before. And we will discover life-saving, earth-changing science and technology along the way.
We're delving deep into what science can be achieved by humans working together with robotic capabilities and future infrastructure to support a long-term human presence at the moon.
The Artemis generation stands ready to return humanity to the moon and then to take us further than ever before to Mars. Onward and upward.
We are going to the moon, to deep space, and to Mars. Humanity will venture further out into our solar system than ever before. But the history that awaits us requires a first step.
This is a story of a mission that represents that essential first step to the moon. A mission that has become the first in a series of increasingly complex missions to expand the bounds of human exploration. This is the story of Artemis 1.
3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
Artemis 1 was a first flight that set new records of performance, exceeded our estimates for efficiency, and established new safety baselines for human flight into deep space. All before returning from this journey, plunging through Earth's atmosphere, and arriving safely back on our home planet.
Good morning, St. Thomas, St. John, St. Croix. Welcome to the annual UVI NASA Outreach event. My name is Christina Chanas. I'm with the University of the Virgin Islands College of Science and Math. I'm a research specialist here at the university, and part of what I do is STEM education and outreach. Today we have a really exciting presentation and guest speakers from NASA Exploration Ground Systems from Kennedy Space Center. But before we begin, I'd like to take a moment to welcome University President Dr. David Hall. Dr. Hall, take it away.
Good morning. My name is David Hall. I am the president of the University of the Virgin Islands. I have been president here for over 14 years. This is my 15th year, and it is always exciting to be able to welcome our NASA partners. They have partnered with the university for so many years, and it has really made a difference. This program in particular is one that is very special, and so I want to welcome all of the students who are participating either in person or participating online. I also want to have a special shout out to our teachers who are participating in this program and are the ones who nurture the students who participate in this program. You are their heroes, but you are our heroes as well. In addition to the wonderful students who are participating from the Virgin Islands, we have students who are participating internationally. And I just want to mention a few of the places that we have connections with. There are students here from South Africa, the Philippines, the DC International School. We also have students in Florida who are part of the Palm Beach School and the Naples Classic Academy. Our deep gratitude to have this international diversity of students participating in the same program. Uh, as Virgin Islanders, we are always proud when individuals go off and do great things and then come back and share their knowledge and insights with us. There are two individuals who are part of our family, but part of the Nassau family, Ms. Fullwood and Dr. King. They are participants and will be sharing information with the students, and they are a shining example that the Virgin Islands produces excellence, and we are glad when that excellence comes back and shares with us. Um, I also want to thank the Montessori School and International Academy. They were the ones who launched this initiative back in 2013, and the University of the Virgin Islands is so thankful for their leadership, but we are glad that we have been able to take this over and to move it to even greater heights with the leadership of Christina Chans and David Morris and others who participate in our physics program. And one of the things I hope you understand, especially to students who are considering pursuing higher education, and I hope all of you are, that the University of the Virgin Islands has an outstanding physics program. We were attracting students for a number of years through our applied mathematics program and our engineering partnership with numerous institutions around the nation. We still have that program in existence. However, a number of years ago, we were able to develop a bachelor's degree in physics and have a focus on astronomy, a focus on engineering concentration, and that has attracted many students to us. And what I am proud of is that in just 4 years, we have been able to graduate 14 students with that degree, that is the BS in physics. Many of those students are now pursuing a PhD in physics. Some of them are in the workforce, doing great things as well. So that is another example of how the university is able to attract students from around the world, cultivate them in a very special field, and finally able to contribute to NASA. One of the reasons we wanted to have this program was so that we could be a supply chain for the talent that NASA and other federal agencies and private agencies need in the workplace. And so finally, I just want to say to all of the students gathered that we would love to have you consider us as an institution for you to pursue your educational dreams. And especially to those who are in very cold climates, it would be wonderful to pursue your degree at a place where the temperature is always in the 80s, where there's a beach right on your campus, and where you can enjoy studying and having a wonderful time year round. And for those of you who are Virgin Islanders, please remember that we are one of the few institutions in the nation that offers free tuition, and that is complete coverage of all of your costs. And it is the way in which the government and the university are saying to you that we are investing in your future because we want you to invest in our future. So thank you all for participating in this exciting program. Again, I want to thank NASA for its investment in the future of this nation, because all of you, no matter what you think you want to do in the future, you are our best weapons for moving science forward, moving technology forward, and moving this nation and world forward. So welcome again to the program, and I hope you have a wonderful and exciting day. Thank you.
Again, good morning, everyone. Before we get started, I want to welcome Sprav School in St. John, St. Peter, St. Paul, our seventh day schools, Moravian, our Montessori schools, our E4USA schools. Thank you, DC International, for being here with us. Charlotte Amalie, Ivana Eudora Ken, Central Complex, Moravian, Homeschool, all of our public, private, and parochial schools. Welcome to our international and national guests. Thank you. Before we get started, I'd like to show you a science communication video from Lockhart K through 8, formerly the Adelita Cancrine, under the direction of Miss Cecile Penn, the science coordinator, and Dr. Molinar, who was a teacher there and is now back in the Philippines at the University of the Philippines.
Hi, I'm Kanaisha Salus, an 8th grade student, and I'm a future astrophysicist.
Hi, I'm Kaylee Charles, an 8th grade student, and I'm your future physicist.
We are the UVI Water Ambassadors from Adelita Cancrine Junior High School.
Many know the USVI as a beautiful place in the Eastern Caribbean, but let's share a little bit about our history. The United States Virgin Islands, officially the Virgin Islands of the United States, are a group of Caribbean islands and an unincorporated and organized territory of the United States. The islands are geographically part of the Virgin Islands archipelago and are located in the Leeward Islands of the Lesser Antilles to the east of Puerto Rico and west of the British Virgin Islands. The U.S. Virgin Islands consist of the main islands of St. Croix, St. John, and St. Thomas, and 50 other surrounding minor islands and cays. The total land area of the territory is 133.73 square miles. The territory's capital is Charlotte Amalie on the island of St. Thomas, previously known as the Danish West Indies of the Kingdom of Denmark, Norway, from 1754 to 1814, and the Independent Kingdom of Denmark from 1814 to 1917. They were sold to the United States by Denmark for $2,500,000 in the 1917 Treaty of the Danish West Indies, and have since been an organized, unincorporated United States territory. The U.S. Virgin Islands are organized under the 1954 Revised Organic Act of the Virgin Islands and have since held 5 constitutional conventions. You can see the islands of St. Thomas and St. John. We are famous for our beautiful beaches, clear blue skies, and festivals that bring millions to our beautiful island.
In the USVI, there's constant study and research of extreme weather and drought.
Details of a dire situation in the territory when it comes to the continuous agriculture is alerting both the farming community and the U.S. drought monitors have listed the territory as severe and
Researchers at local and federal agencies such as the VA Department of Planning, Natural Resources, and Water and Power Authority, along with the VA Territorial Emergency (MDT) Agency by TEMA and the U.S. Drought Monitors, along with our federal partners at USDA, USGS, Environmental Protection Agency, and National Weather Service, National Oceanic and Atmospheric Agency, among others, who work day and night to research and study climate and the impact of climate change so that we can protect our community. You may not know, but many in the USVI actually collect rainwater for home use, as many do not have piped-in city water, much as they do in other areas across the world. Researchers actually study data from the USVI to study climate, and no, you can't see it because we have had rain, but in January, February, and March, you can see harsh distress of vegetation, erosion, and compare these images to others taken over longer periods to determine what the impacts of droughts are in the USVI and the region. USDA and the Farm Service Agency work hard to aid farmers in the territory when severe droughts impacts the islands. Right now, we are facing drought conditions, and it appears, based on research here, the territory is heading into an earlier drought. The video of the ponds shows them filled, which is a blessing in our community, but these ponds have not been filled since 2015, and just as recent as December were nearly empty. Remember, you can do your part to address climate change, conserve water, don't waste food, plan ahead for natural disasters, and learn about science and STEM from every inch of your community, including school, when visiting and going out in your community and become an ambassador to protect our community.
To our fellow future scientists watching today from all across the globe, we hope you enjoyed the presentation presented to you by the students from across the USVI and the nation as we learn more from NASA scientists about how we as students can join the ranks for NASA as we begin our journey to the USVI and other universities and study STEM to make the world a better, safer place for all of us.
We are the UVI Water Ambassadors.
And now, on to the NASA presentation. Thank you.
Thank you. And now, without further ado, I'd like to introduce my colleagues. Just a short note, teachers, if you have questions, please put your school, your grade, and your question in the chat on Teams, Facebook, or YouTube, and we'll pull them down and read them out as we go along and as time permits. At this time, I would like to introduce you to my colleagues from NASA, Miss Megan and Hunter. Take it away, guys.
Thank you so much, Christina. I am Megan Epperly. I work for NASA's Exploration Ground Systems program here at Kennedy Space Center in Florida. I'm going to pull up our presentation and we will go ahead and get started. All right, so just a little bit about me quickly. Like I said, I'm Megan Epperly. I'm the Education and Outreach Coordinator for NASA's Exploration Ground System. I'm originally from Virginia, but I've lived down here in Florida for going on 5 years. I have a bachelor's degree from Radford University in Virginia in communication studies. With that, I went into marketing right after college for 7 years. And then during the pandemic, after I moved down to Florida, I decided to pursue my master's degree, and I got that in education. And then after I finished up with that is when I made the transition over to NASA, and it's been a dream ever since. I have a couple pictures here on the left just to point out some of the cool things I get to do. I have a picture inside of the vehicle assembly building on the left. You can see how big that building is just by how small I am in that picture. And then I also have a picture there with my son when he was 6 months old. I was able to do an outreach trip to Puerto Rico. It's his first time on a plane, and he got to learn all about NASA. But that is enough about me for now. I would like to go ahead and pass it off to Hunter, who is a business management integrator and analyst for Exploration Ground Systems. So you can go right ahead, Hunter.
Thank you so much, Megan. I'm so happy to be here and to be able to talk with everybody. I'm really fortunate. I love talking about what I do and what NASA does, and what the Artemis program is doing. Here's a little slide about me and what I do. My name again is Hunter Goodnow. I am a business management integrator and analysis for Exploration Ground Systems, which is the part of the Artemis program. We are in charge of stacking, launching, and recovering the rocket in the capsule. I went to University of Central Florida as well, so go Knights. I got a bachelor's in economics and I have a minor in sociology. Before NASA, I actually worked in retail management for about 8 years, and I didn't actually get a high school diploma until I was 26 years old, and I got a GED, where you just kind of take a bunch of tests for those who had dropped out of high school. So I actually started my career a little later, and I'll go in further into that later on. And through college, I worked in an Italian restaurant to try to afford to be in college, and learned a lot about food. And it's actually one of my hobbies. So down when I'm not at work, I am a home chef and I like to bake bread. I work on my house a lot. I'm a new homeowner, so I am attending the YouTube University, as I like to call it, as I learn how to do everything to fix my home. I love video gaming, tabletop gaming, board games, and I like going to concerts. And I went to the Taylor Swift Eras Tour last year, so a little flex there. These pictures mean a lot to me. Up in the top left, that was actually my first week as an intern. Starting out at NASA, and that is in the Vehicle Assembly Building, which is the same building behind me here. So that's the outside of it. And then that's a photo of me inside of it. And that is where we stack the core stage, the solid rocket boosters, and the capsule, and put it all on the crawler and then roll it out to the pad. It has the largest doors in the world, and you can roll the Statue of Liberty right on into it. I really like that picture because even though you don't see my face, you do see me kind of looking out into this incredibly large building. And it's also kind of a representation of all of the great things that you can do at NASA if you just apply yourself. And then the picture to the right is me fast forward 5 years later. So definitely no longer an intern. And that's me at MegaCon in Orlando on a panel. NASA does panels where we get to just answer questions very similar to this, and I was able to answer questions and talk about what I did, and it's just a great little kind of path. You see my first day, and then you see me talking about everything that I've learned and everything that I'm contributing to. And there's a few pictures at the bottom of me at a concert, me making homemade pasta, and my amazing cat, because I am a proud cat dad. But yeah, we can move on. So I am here to talk to you all about the Artemis program and all the missions that we are currently working on. So the Artemis program is named after the twin sister of Apollo. Artemis is the goddess of the moon in Greek mythology. The reason why we wanted to call this program the Artemis program is because we had the Apollo program in the late 60s and early 70s, which was the first time we went to the moon. And now we're going back, but this time to stay. I always think of the Artemis program as the next and new generation of NASA and deep space exploration and science. You thought about the Gemini program and then the Apollo program and then the shuttle program. And now we are in the next phase and the next generation, which is Artemis. I do hope that in decades from now, when we are consistently sending humans into deep space, we'll look back and think of the Artemis missions that we did today as the real first milestone that paved that new level of science and that new level of exploration. And I really wanted to just say that the Artemis generation, when we say that, we're not saying the people at NASA. A space generation for a country or for the world is a collective effort. It's not only us who are actually working every day on the program, but it's the teachers in the schools that inspire those to go into science degrees. It's the students who get excited when they can see a rocket launch, or if they get a NASA patch, they have to wear a NASA shirt, and they're just excited about that. It's the parents, it's the tech companies and commercial partners that create new technology that NASA then can use to be successful. It's the federal government and giving us the support that we need, and it's the international partners like the European Space Agency and JAXA, the Japanese Space Agency. It is not just something that NASA does, it's something that the United States does and the world does. We have a slogan for the Artemis program where we say, "We are going." And the "we" includes everybody today that's listening and being a part of this, and everybody that knows about the Artemis program and supports it. So it's super, super exciting stuff. But the real question is, why do we go to the moon? We have a short video to kind of talk about that.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science. It holds opportunities for us to make discoveries about our home planet, about our sun, and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
And because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
Man, that's such a great video, and that's a NASA team that makes that video. So we have a great team of public affairs people and video editors and video makers, and it's not just engineers. And those videos are amazing. Yeah, so that video explains why we're going to the moon, and I want to kind of just touch on how we're doing it. So the Artemis program is actually, we call it a tri-program. So we actually have 3 different programs all working together towards a common goal. Like I mentioned before, and so did Megan, that me and Megan work on the exploration ground systems, which is the one of the 3. But we stack the rockets. We are not the ones that actually build them. So we have 2 other programs that are building the rockets and the capsules. And the rocket is, we call it the SLS program, and they are building this. And the SLS stands for the Space Launch System. This is the rocket that takes us back to the moon. You can see in this photo here, you see this large orange area, and that's our core stage. And then you have the two rockets on the side that are called the solid rocket boosters. And together, those can generate 8.8 million pounds of thrust. One of the most important things is the ability to go far and lift a lot of weight far. And it's really important to make sure we bring everything we need to go to the moon, because we're not just going for a mission and coming back the way that the Apollo missions were. We're actually going and we're staying, and we're trying to do sustainable science. What's amazing about this rocket is it's flexible. So we are able to either carry equipment or we're able to carry astronauts, and we can kind of change it up slightly depending on what our mission is. It's absolutely incredible. It's the only exploration class vehicle capable of sending humans into deep space currently, and it is the most powerful rocket that NASA has ever made. So that's the thing that lifts us up. But where do we put our crew, and what actually goes all the way to the moon? And we do that on something called Orion. Orion is also the third part of our program. So Orion actually has the crew module where we put our crew, and it's the space vehicle that will go to the moon and come back. What's really amazing about our Orion capsule is it's able to accommodate 99% of the human population, not all at the same time, obviously. What I mean by that is that it allows different astronauts of all different sizes to be able to fit. So it allows more opportunity to get the best and most capable astronauts for the job, regardless of if you're a 4'10" female or you're a 6.5 male. The Orion's able to fit you, which is absolutely incredible. It's also 30% larger in volume than the Apollo capsule, which doesn't sound like a lot, but if you've ever come to Kennedy Space Center and see how big the Apollo capsule was, I'm really happy that the astronauts this time around have a little bit more space. And it has extremely amazing heat shields. A heat shield is required for when the capsule comes and splashes back down. It goes through our atmosphere, and our atmosphere can get very, very, very hot. So we have a heat shield that's able to withstand temperatures of over 4,000 degrees on re-entry. So that's how we're getting there. So I want to talk a little bit about the missions that the missions that we're working on currently, and what we've done and where we're going now. So Artemis 1. Artemis 1 was the first Artemis mission, and it already happened. I hope you've heard about it. We already went back to the moon, although we haven't put astronauts on the Orion capsule yet. We did send it. It was fully human rated. We launched that rocket on November 16th, 2022 at 1:47 a.m. It was very early. A lot of us were there. It was easily the highlight of my career. Being the first launch of a new program is always a little you get a little nervous. We test and we test and we simulate and we test so much, and we really put so many years into it, but until you really see it launch and be successful, it's nothing more than theoretical. It's nothing more than diagrams and videos and things, and to see it all work and all the hard work pay off, to say we not only we are going, but now we can say we did go and we did it. And I highly recommend, no matter where you are in the world, when we do Artemis 2, which I'll talk about in a moment, figure out a way to see it live, or just watch it on a stream. It really is history. So this is a little trail of where the Orion capsule actually went, what our path was. So we slingshotted around Earth and then launched out to the moon. We did kind of a figure 8, and then those dotted lines way out there was the furthest that a human-rated space capsule has ever gone in the history of mankind. And it was absolutely incredible. And then we have a actual selfie. Yes, NASA takes selfies too. So this was a selfie that Orion took while they were on the other side of the moon. It's just absolutely incredible that the detail of this photo and how close we were, and it really gets me excited about what type of science and that we're going to be able to do on the moon, and what kind of information that we're going to get. And then after it went to the moon, obviously we want to bring it back. So this is a quick little image and video of what a splashdown looks like with the parachutes. So that is the Orion capsule splashing down in the Pacific Ocean. That was after a 25-day mission. It was recovered by NASA's Landing and Recovery Team, which is part of EGS, along with the U.S. Navy and the Department of Defense aboard the USS Portland. On Artemis 2, we will have humans on that as well, so we want to make sure it all works. So Artemis 2. Which is ahead of us. Now that we've proven that everything works, we want to put astronauts on it and send them out there. So Artemis 2 is going to be at the September of 2025. It will have 4 astronauts on it, and it's gonna go to the far end of the moon, and we're gonna prove that our Orion capsule can have humans, bring them back safely. We're gonna get our crew to be used to the system and do it for real. What's the most important part of Artemis 2 is the crew. They are, in my opinion, those are our that's who we work for. NASA's #1 goal is always safety, and they are going to be the real heroes and the household names that we're going to have as the first humans that have gone back to the moon in over 50 years, and the furthest that we've ever sent humans since we started exploring space as a planet. So we have a little video here to talk about Artemis 2 crew.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign and missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together. When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon.
Stage engine start.
Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence
on the lunar surface.
We are ready.
We are going
to the moon
for all humanity.
We are Artemis.
Man, another amazing video. I want to just take a moment and I want everybody to look at this crew, and I want you guys to look at these names. And those of you in school, I know that you've looked in history books and you've been taught about the first ones that went to the moon before during the Apollo program. You know, Neil Armstrong, Buzz Aldrin, Mike Collins, and you read those but you didn't see them. You know, it's not something that you experienced. But these names and these faces in this mission, and then the Artemis 3 mission, those are going to be things that you do experience. And it's not going to be just in a history book for you. It's going to be a memory for you. And so it's just so exciting to be really a part of it and be part of this generation. And we haven't announced the Artemis 3 crew yet, but this crew is amazing. They're, like they've said, they're so humble. And I can't imagine a better crew for this mission. So moving on to Artemis 3, which will be a year after Artemis 2. And this one, we land on the moon again for the first time in over 50 years. What's really important about Artemis 3 is not only will we land on the moon, but we will have the first woman and the first person of color land on the moon. We are extremely, extremely excited to have that happen. At NASA, we feel really strongly about diversity and inclusion. And just like Christina said in the video about the crew, how she saw the Earthrise over the moon, and she was inspired to go off and pursue a career as an astronaut. And I think it's extremely important to know that no matter where you are, what you look like, where you're from, that you see people that look like you that accomplish amazing things. So we're very, very excited to have that happen and be a part of that. 2 astronauts are going to land using what we call our human landing system, and that's going to be actually supported by our commercial partners of SpaceX and Blue Origin. And they're going to actually go about 3 weeks earlier and bring a lot of our systems there, and then we will bring our astronauts there as well. So not only does NASA do it, but we are so excited to be with our commercial partners, and they're extremely helpful, and we learn from each other. It's so exciting. So what do we do once we land on the moon? What's next, right? We've done this already. Artemis 4, and keep in mind, we are working on all of these missions right now at the same time. Artemis 4, we will start building our space station. It's called Gateway. It's going to be a space station that goes around the moon, very similar to our International Space Station that we currently have that goes around Earth. That's going to be the first step in having a constant presence on the moon. The values of a space station are we can dock on a space station, then go back and forth from the moon, opposed to bringing everything we need with us and bringing everything back. It's going to allow us to live longer up there as well, and not just go and come back like that. It's going to be super exciting, and that'll happen a little after Artemis 3. We are working on all of these right now. I'm in meetings where we talk about Artemis 4, just like we talk about Artemis 3 and Artemis 2. And all 4 of these are only the beginning of what we're going to be doing. So if all of that sounds amazing to you and you want to be a part of it, I'd love to now switch over to a video talking about careers, and I'll go into that a little bit.
We need you, all of you, to go for everyone.
Where no one has gone before, to help humanity reach our collective goals of exploration and discovery.
Unlock your potential side by side, interns, civil servants, and contractors.
You will be mentored, you will be coached, and you will be challenged for your personal growth and for the success of the Artemis mission.
Your talents,
your skills,
and your perspectives are needed to make this possible.
Splashdown.
Begin your journey from the ground up. The time is here.
The time is now.
I know everybody in that video, and they're all awesome, and they're all great workers. Yeah, so the time is now, and we have so many different jobs and responsibilities and places you can work out here. All of these right here, these are a lot of our engineers, and these are a lot of our STEM related jobs. And you can see, although they all say engineer, they are so different. We have a software developer if you're into coding. We have avionics, we have mechanical if you just are good with building things and figuring things out. We have project managers where, although you might not want to be the one doing it, but you're great at overseeing things and making sure everything gets done. All of these jobs are difficult but rewarding and challenging, and you'll probably end up doing more than one of these jobs. And all of these go through a STEM degree: science, technology, engineering, and math. And it's such a fulfilling thing to do. But at NASA, we don't only need science majors and technology majors. NASA does so many things and needs so many types of skills. Like today, I mean, all of this wouldn't be possible without the amazing people in our outreach program, our social media. I mean, you see anything on Instagram or Facebook, NASA, we're doing that. Graphic designing, robotics, geologists. Anything that you love to do, if you're good at it, there's probably a place here for you. Me, I mentioned earlier, I didn't get a high school diploma until I was 26 years old. And I never thought in a million years that I would be working at NASA. I didn't think, I wasn't interested in science. I might as well have been the president of the United States in terms of possibilities for me. But I kind of just decided I wanted to do something more. I got a GED, and then I moved on to going to college and ended up graduating from University of Central Florida cum laude, meaning that I finished in the top 5% of my class. I was a horrible student in high school, but I found something that I loved, and I kept working hard, and working at NASA slowly became more of a possibility. And then once I got here as an intern, I found my people, and it was so amazing how supportive everybody is. And we really do hope that we work as a team and teach what you need to learn. You can do any job out here if you try. If you're thinking there's no way I'm going to work at NASA, I want you to throw that idea away. You definitely can work here. And I think that following the passion that you love and just working hard will get you here. I know my mom's super proud that I'm here, and I think that if I told her 10 years ago I'm going to work at NASA, she probably would have been like, yeah, we'll see what goes on. You're capable, but we see what you got in high school. And she's so proud now. And on this next slide, you're going to see a few people that really made it happen, and we're so proud to have them on our team. So they actually come from the Virgin Islands. So we have Dr. Rudolph King, the senior researcher at Langley Research Center. He graduated at Ivana Eudora Keene High School, class of 1983. And Simone Fullwood, senior systems engineer, raised in St. Thomas and attended the Adelita Cankren Junior High School. When you ask anybody, how did you get to NASA? Did you know you were going to work there? I guarantee you that 99% of the people that work here, when they tell their story in there somewhere, is I never thought I would work here. And we all have paths that got us here that are unconventional, because although NASA wants to hire the best and the brightest, what we mean by best is the best people, not necessarily the best at your job. And the brightest means, can you problem solve? Not necessarily can you get the best grades, but can you problem solve? Can you work as a team? Can you communicate well? There's skills that we look for in people, and not necessarily just how perfect your statistics are on your resume or on your grades or on your, of course, get good grades, but NASA is very, very possible for everybody listening to this. I promise you that if I can do it, anybody can do it. And I'm so happy that I made that decision to apply to an internship. And it just worked out. And I kind of I pinch myself every day that I cannot believe that not only am I working at NASA, but I'm working on the Artemis program and making history with some of the most brilliant people on the planet. So I definitely say go for it and try, because the only thing that's going to stop you is you. And I think we have a quick video of Joe Acaba.
Hello, I am NASA astronaut Joseph Acaba, coming to you from the Johnson Space Center in Houston, Texas. I studied and worked hard, graduating high school in California, and then earning both a bachelor's and master's degrees in geology. While working as an astronaut after my last flight, I earned a master's degree in education, an area I strongly believe in. Education opens doors to so many opportunities. Much of my life has revolved around education, both as a student and a teacher. My education got me to where I am today. When I became an astronaut, it was like going right back to school. We have to learn all about our spacecraft, we learn to speak Russian, and we train in high-speed, high-risk operational environments to help us get ready for a space mission. I've flown 3 missions, one aboard the Space Shuttle Discovery, and twice on the Russian Soyuz spacecraft. Missions lasted from 2 weeks up to 6 months. Here at NASA, we continue to advance the research and technology to return humans to the moon. We are still pushing forward with plans to send the first woman and first person of color to the moon under NASA's Artemis program. No human has set foot on the moon since Apollo 17 in 1972. So the possibility of landing on the moon is incredible. On November 16, we watched Artemis 1 launch and execute the first lunar orbit in more than 50 years. This was the first integrated flight test of NASA's deep space exploration systems, the Orion spacecraft, Space Launch System rocket, and the ground systems at Kennedy Space Center in Cape Canaveral all came together for this extraordinary mission. Artemis 1 traveled a total of 1.3 million miles to the moon and back. After a 25-day mission, Orion successfully splashed down on December 11th in the Pacific Ocean. The capsule is now back at Kennedy Space Center, where it is being tested and studied. Up next will be Artemis 2, taking astronauts to the moon, and it will be here before we know it. I'm currently the chief of the astronaut office, ensuring crew safety and mission success. My hopes are to inspire the next generation of explorers and leaders, and to help elevate, build awareness, and highlight the teaching profession and its importance to our society. As you learn more about NASA and all that we do, I want you to remember that we are all crew members aboard a space station, our beautiful planet Earth. Viewing the Earth from space reminds us that we all share the same orbiting sphere as we travel around the sun together.
All right, thank you so much, Hunter. That was so great. We learned so much about the Artemis campaign and everything we're doing to get back to the moon. We're so excited. And I think maybe we had some questions come in while we were presenting, and I will have you, Christina, run those.
Okay, here we go. Let me see. I'm trying to get back up through them. Here we go. Okay. One of the questions we were asked is, will the space capsule have a lab, or will you do that research once they come back home? And if they're doing research at home, how will they secure and prepare the samples?
That's a really, really good question. So how will they do testing there, or will they do testing back on Earth? For the first few missions, they might do some minor testing while they're there, but a majority of everything that we want to do, we want to bring it back to our labs here. We want to do testing here. As for samples, we have multiple levels of clean rooms that we use whenever we do anything that could come into contact with anything we don't want it to. So when we bring our samples back, we do bring them through a, depending on what it is, we actually bring it through levels of clean rooms before the samples or the person can go into a lab. And then if you can picture people wearing, different types of suits that protect any of their oils or hands. So we take cross-contamination extremely seriously, and we have a lot of those labs here at Kennedy Space Center. And we will do a lot of that here. Now, that being said, once we get to our Artemis 4 and beyond, we start building our gateway, which is our space station that goes around the moon, we do expect to be able to do some better testing while we're out there, so it doesn't take the time to bring it back here and do it here. It just depends on what it is and how careful we need to be in terms of cross-contamination. That's a great question.
So with that said, there's a follow-up question, and that is, will you bring moon rocks home? And if so, would that be a geologist, or what type of scientist would work with that?
Yeah, we absolutely want to take samples back, and depending on what we want to test with those samples, a geologist would almost certainly be an option for us to do that. I mean, it's been theorized that the moon at one point was part of Earth, so understanding a geologist, understanding the makeup of all the different minerals and rocks that the Earth is made out of, I'm sure that there would be an expertise there that would lend to studying the samples that we pull back from the moon.
That's awesome. Okay, I love this question, and I'm not sure I captured it exactly correct, so bear with me. Can you talk about how many designs there were for the rovers, and do they change, or the rocket, and do they change as it's being developed?
Oh, I can go to great length.
Oh, yay, that's a really good question. Awesome.
I won't nerd out too much because we only have so much time. I work in those rooms with those development discussions, and So we have multiple designs. Usually designs happen in percentages. So we'll have a 45% design, and then we'll have a review, and then we'll have a a 90% design, and then we'll have a review, and then we go from there. But that being said, as we're designing things, we realize that things need to change. So we'll do a test along the way.
Oh, what happened? Oh my goodness. Okay, there you go. Keep
Are we
going.
good?
Yeah.
Yeah,
Okay.
yeah, we just lost you for a second, but you're back.
Oh, okay, I'm good. All right. So yes, we have meetings and things will change along the way. Just like if you were to build a house, the tile didn't fit exactly how you thought, or the paint color wasn't what you thought it was going to be. And so you have to go back and you have to ask yourself, okay, what are these new requirements and how are we going to implement those? And how do we do it without losing any of our schedule and without doing it for any more money? So yes, the designs definitely change along the way, and there's a lot of people who look at these designs and ask a lot of really hard questions. So we make sure that we make the rocket and the whole mission as successful as possible.
Okay, before we wrap up, I want to hit these two questions because I think they're really, really great. One of which is, what can high school students do today, right now, if you're in 9th, 10th, 11th, or 12th grade, to prepare themselves for college so that they can be on a pathway to get a NASA internship? Do you have any advice about that?
Yeah, absolutely. So I know this is going to sound a little cliche, but I think that anybody in high school, of course, it's going to take.
Oh, there he goes. Okay.
We're good?
It might be your VPN, Hunter, but we can address that after. But
All right. So I would say for anybody listening, be curious, keep challenging yourself, asking questions, always go and ask yourself why, and go find an answer. Work hard, work really, really hard, and learn how you learn. At NASA, we learn new things so much. I feel like every day something's fallen in front of me and they're like, okay, you need to now learn this and understand it. And I think more than memorizing the information that you are in school, learn how you learn best, and then voice that to others so they can teach you in the best way that you can learn. I think that those are great skills that will carry you into NASA or somewhere else. I have found that those are really, really, really important. But that being said, there's also a lot of paths that I know Christina can talk on the actual ways to apply to internships.
So I just would like to share with you the University of the Virgin Islands College of Science and Math and the physics program has a new program at UVI, which is called the UVI NASA Pre-Engineering Academy. It is a 1-week live in the dorms, eat at the cafe, meet NASA scientists, work with university professors, and take part in an engineering program where you do hands-on activities. That application is going to come out in the next week or so. Look for that. If there's a hard deadline on it, there's 3 things that are required. A survey, which will be sent with the application link, a 1 to 2 minute video of why you want to come, and then an essay that explains your interest in STEM. So look for that and make sure that you do that, because that'll get you on your pathway from your high school to me, and this is for Virgin Islanders, and then that pathway will help you get onto the pathway for NASA. And those are for STEM students. It does require a letter of recommendation from one of your teachers or your counselor. If you're seriously going to apply, I have 20 slots, 10 for St. Thomas, St. John, and 10 for St. Croix. So get your application in early, start talking to your teachers and counselors about your letters of recommendation, and look for that with your STEM teachers because it'll be coming at you soon. Last question we want to ask is, does Mars have water and or ice?
We found traces of evidence that it has water. We haven't gone and really stepped foot on it, but there's definitely evidence that it has or once had it. And that's actually a really great question because of how important ice and water are. When you send astronauts to Mars, you can't send them more more resources if they run out. If they run out of water, we can't just, Amazon 2-day prime them some more water. It won't get there in time. Mars is very, very far away. So knowing if there is not only ice, but ice that we can use to create water and possibly oxygen for those science people out there, there's oxygen in water. So maybe we can possibly generate oxygen from the water. Is extremely, extremely important to make sure that the crews that eventually go to Mars are self-sustaining when they get there and can stay there for a long period of time.
That's awesome. Megan, as we get ready to close out today, do you have any final comments that you'd like to share with the group?
Yes, I would like to just say thank you to everybody who tuned in today that was here to learn about everything that we're doing and how you can possibly get involved one day. If you are interested in STEM or not, or interested in working at NASA, there are several different resources that you can use to learn a little bit more. I would go to nasa.gov/careers, where you can look around on there to see all the different jobs that you could potentially have out here at NASA. So if you have an interest in cooking, crafting, science, math, geology, you can see all the different jobs that you could do. Also, for the older students who are watching who are looking into internships, they can start as early as high school. So you can see those at interns.nasa.gov, and you'll see all of your options there for internships and how you can get involved starting now.
Awesome. And teachers, there's lots of resources, and they also hire just a boatload of educators. So take a look, see if you want to get off island and have an opportunity to work for NASA and be a part of the new frontier. My name is Christina Chanas. I'm with the University of the Virgin Islands College of Science and Math. I want to thank everybody for joining us from the international communities, our stateside partners, our BVI and Puerto Rico partners, along with all of our Virgin Island youth and educators. To our educators, we love you. We appreciate you. You are the true superheroes of tomorrow. Thank you so much, and we'll see you next time. Have a good weekend, everyone.
Bye, everybody.
exploration. As we sail on this new cosmic sea, there's so much to learn. There's so much to be excited about.
Artemis is different from anything humanity has ever embarked on before. And we will discover life-saving, earth-changing science and technology along the way.
We're delving deep into what science can be achieved by humans working together with robotic capabilities and future infrastructure to support a long-term human presence at the moon.
The Artemis generation stands ready to return humanity to the moon and then to take us further than ever before to Mars. Onward and upward.
We are going to the moon, to deep space, and to Mars. Humanity will venture further out into our solar system than ever before. But the history that awaits us requires a first step.
This is a story of a mission that represents that essential first step to the moon. A mission that has become the first in a series of increasingly complex missions to expand the bounds of human exploration. This is the story of Artemis 1.
3, 2, 1. Boosters in ignition. And liftoff of Artemis 1. We rise together back to the moon and beyond.
Artemis 1 was a first flight that set new records of performance, exceeded our estimates for efficiency, and established new safety baselines for human flight into deep space. All before returning from this journey, plunging through Earth's atmosphere, and arriving safely back on our home planet.
Good afternoon, everyone. My name is Christina Chanas, and I'm with the University of the Virgin Islands. I am a research specialist here at the university, and I work in outreach. Before we get started, I want to give a quick shout out. Sprague School on St. John, St. Peter, St. Paul, Seventh Day, schools on both St. Thomas, St. Croix, Montessori schools, St. Thomas, St. Croix, the DC International School, E for USA group, Charlotte O'Malley, our E for USA group at Ivana Eudora Ken, Central High School, Complex High School, Moravian schools, our homeschool, and all of our public, private, and parochials that I may not have mentioned, and for all of our guests in the continental United States, along with our internationals. Welcome to our final session, 5 days, 3 islands, 16 events, and this is the last one. Thanks for checking in and catching this. Before we get started, I'd like to welcome Dr. David Hall, University President, to share with you a few welcoming remarks. Dr. Hall?
Good morning. My name is David Hall. I am the president of the University of the Virgin Islands. I have been president here for over 14 years. This is my 15th year, and it is always exciting to be able to welcome our NASA partners. They have partnered with the university for so many years, and it has really made a difference. This program in particular is one that is very special. And so I want to welcome all of the students who are participating either in person or participating online. I also want to have a special shout out to our teachers who are participating in this program and are the ones who nurture the students who participate in this program. You are their heroes, but you are our heroes as well. In addition to the wonderful students who are participating from the Virgin Islands, we have students who are participating internationally. And I just want to mention a few of the places that we have connections with. There are students here from South Africa, the Philippines, the DC International School. We also have students in Florida who are part of the Palm Beach School and the Naples Classic Academy. Our deep gratitude to have this international diversity of students participating in the same program. As Virgin Islanders, we are always proud when individuals go off and do great things and then come back and share their knowledge and insights with us. There are two individuals who are part of our family, but part of the Nassau family, Ms. Fullwood and Dr. King. They are participants and will be sharing information with the students, and they are a shining example that the Virgin Islands produces excellence, and we are glad when that excellence comes back and shares with us. I also want to thank the Montessori School and International Academy. They were the ones who launched this initiative back in 2013, and the University of the Virgin Islands is so thankful for their leadership, but we are glad that we have been able to take this over and to move it to even greater heights with the leadership of Christina Chans and David Morris and others who participate in our physics program. And one of the things I hope you understand, especially to students who are considering pursuing higher education, and I hope all of you are, that the University of the Virgin Islands has an outstanding physics program. We were attracting students for a number of years through our applied mathematics program and our engineering partnership with numerous institutions around the nation. We still have that program in existence. However, a number of years ago, we were able to develop a bachelor's degree in physics and have a focus on astronomy, a focus on engineering concentration, and that has attracted many students to us. And what I am proud of is that in just 4 years, we have been able to graduate 14 students with that degree, that is the BS in physics. Many of those students are now pursuing a PhD in physics. Some of them are in the workforce, doing great things as well. So that is another example of how the university is able to attract students from around the world, cultivate them in a very special field, and finally able to contribute to NASA. One of the reasons we wanted to have this program was so that we could be a supply chain for the talent that NASA and other federal agencies and private agencies need in the workplace. And so finally, I just want to say to all of the students gathered that we would love to have you consider us as an institution for you to pursue your educational dreams. And especially to those who are in very cold climates, it would be wonderful to pursue your degree at a place where the temperature is always in the 80s, where there's a beach right on your campus, and where you can enjoy studying and having a wonderful time year round. And for those of you who are Virgin Islanders, please remember that we are one of the few institutions in the nation that offers free tuition, and that is complete coverage of all of your costs. And it is the way in which the government and the university are saying to you that we are investing in your future because we want you to invest in our future. So thank you all for participating in this exciting program. Again, I want to thank NASA for its investment in the future of this nation, because all of you, no matter what you think you want to do in the future, you are our best weapons for moving science forward, moving technology forward, and moving this nation and world forward. So welcome again to the program, and I hope you have a wonderful and exciting day. Thank you.
Thank you, Dr. Hall. It's always so exciting to have you with us. Before we get started, I would like to share with you a bit of science communication from the Adelita Cancrine School. It's a video from last year. Adelita Cancrine is currently Lockhart K through 8. And I really want to give a special shout out to Dr. Ryan Molinar, who was at the school and helped with the video, along with Miss Cecile Penn, the science coordinator up there, and STEM coordinator. Really appreciate the partnership, and you'll see their tourism and science communication video now. Next up.
Hi, I'm Kimaisha Salif, an 8th grade student, and I'm your future astrophysicist.
Hi, I'm Kaylee Charles, an 8th grade student, and I'm your future physicist.
We are the UVI Water Ambassadors from Adelita Cancrine Junior High School.
Many know the USVI as a beautiful place in the Eastern Caribbean, but let's share a little bit about our history. The United States Virgin Islands, officially the Virgin Islands of the United States, are a group of Caribbean islands and an unincorporated and organized territory of the United States. The islands are geographically part of the Virgin Islands archipelago and are located in the Leeward Islands of the Lesser Antilles to the east of Puerto Rico and west of the British Virgin Islands. The U.S. Virgin Islands consist of the main islands of St. Croix, St. John, and St. Thomas, and 50 other surrounding minor islands and cays. The total land area of the territory is 133.73 square miles. The territory's capital is Charlotte Amalie on the island of St. Thomas. Previously known as the Danish West Indies of the Kingdom of Denmark, Norway, from 1754 to 1814, and the Independent Kingdom of Denmark from 1814 to 1917. They were sold to the United States by Denmark for $2,500,000 in the 1917 Treaty of the Danish West Indies, and have since been an organized, unincorporated United States territory. The U.S. Virgin Islands are organized under the 1954 Revised Organic Act of the Virgin Islands and have since held 5 constitutional conventions. You can see the islands of St. Thomas and St. John. We are famous for our beautiful beaches, clear blue skies, and festivals that bring millions to our beautiful island.
In the USVI, there's constant study and research of extreme weather and drought.
Details of a dire situation in the territory when it comes to the continuous agriculture is alerting both the farming community and the U.S. drought monitors have listed the territory as severe and
Researchers at local and federal agencies such as the VA Department of Planning, Natural Resources, and Water and Power Authority, along with the VA Territorial Emergency (MDT) Agency by TEMA, and the U.S. Drought Monitors, along with our federal partners at USDA, USGS, Environmental Protection Agency, and National Weather Service, National Oceanic and Atmospheric Agency, among others, who work day and night to research and study climate and the impacts of climate change so that we can protect our community. You may not know, but many in the USVI actually collect rainwater for home use, as many do not have piped-in city water, much like they do in other areas across the world. Researchers actually study data from the USVI to study climate, and now you can't see it because we have had rain. But in January, February, and March, you can see harsh distress of vegetation, erosion, and compare these images to others taken over longer periods to determine what the impacts of droughts are in the USVI and the region. USDA and the Farm Service Agency work hard to aid farmers in the territory when severe droughts impacts the islands. Right now, we are facing drought conditions, and it appears, based on research here, the territory is heading into an earlier drought. The video of the ponds shows them filled, which is a blessing in our community, but these ponds have not been filled since 2015, and just as recent as December were nearly empty.
Remember, you can do your part to address climate change, conserve water, don't waste food, plan ahead for natural disasters, and learn about science and STEM from every inch of your community, including school, when visiting and going out in your community and become an ambassador to protect our community.
To our fellow future scientists watching today from all across the globe, we hope you enjoyed the presentation presented to you by the students from across the USVI and the nation as we learn more from NASA scientists about how we as students can join the ranks for NASA as we begin our journey to the USVI and other universities and study STEM to make the world a better, safer place for all of us.
We are the UVI Water Ambassadors.
And now, on to the NASA presentation. Thank you.
Thank you, Adelita Cancrine, aka Lockhart K-8 Youth, and Miss Penn. Now I'd like to introduce you to two of my colleagues, Hunter and Megan. They're gonna take it away from here.
Thank you so much, Christina. We are so excited to be here today. We'll go ahead and bring up our presentation so we can get started. All right, so a little bit about me. I am Megan Epperly. I am the Education and Outreach Coordinator for NASA's Exploration Ground Systems program here at Kennedy Space Center. I have a background in communications and marketing. I did that for about 7 years before I joined the NASA team. I am originally from Virginia, but made my way down to Florida about 5 years ago. During the pandemic, I pursued my master's degree in education. I thought no better time when everything was shut down than to go back to school. And I just want to point out a couple pictures here that are kind of fun. I have the one on the left is from when I first started at NASA. I'm in the Vehicle Assembly Building, which is one of the iconic buildings here at Kennedy Space Center. You can see I'm just very tiny in that giant building. And then next to that is a picture I'm really proud of. It is me with my son when he was 6 months old. We did an outreach trip for EGS in Puerto Rico, and he was able to come along. It's his first time on a plane, first time learning all about NASA. And a little bit about me outside of work. I like to cook. I'm really trying to hone in my baking skills, doing that on the weekends. And I also love to travel, trying to bring my son along as much as possible as well. My husband and I are trying to visit every U.S. national park. We're at 13. We have quite a bit to go, but we're making our headway. But if you all have any questions throughout this presentation, as you're learning about the Artemis program, or any questions for myself or Hunter about our career path, just drop them in the chats and we will try and get to those at the end. But for now, I will go ahead and pass it to our speaker today. His name is Hunter Goodnow, and he's a business management integrator and analyst. And he's going to talk to you all about exploration ground systems and the Artemis program.
Awesome. Hello, everybody. Thanks so much, Megan. My name is Hunter Goodnow, and I'm a business management integrator and analyst. I know that's a lot of words. So what I really do for exploration ground systems, we are in charge of stacking, launching, and recovering the Artemis missions, rockets, and the Orion capsules. So just like when you build a house, you not only have a big budget for your house as a whole, and you have a schedule of when your house is supposed to be done, but you also have your specialties like your electricians and your plumbers and your roofers and anybody else who might put the tile in your bathroom, and they all have their own little schedules and their own little budgets. And so you need somebody or a group of people, which is my budget office, to keep an eye on what goes more expensive or goes over the schedule that was planned and what goes under, and how do we kind of change things up as things happen, because of course sending a crew to the moon is far more complicated than building a house. So there is a lot of teams doing a lot of things, and we need a really sharp team to keep an eye on everything and make sure that we're spending the money where we need to and everything ends up happening on time. So I'm part of that team. So this first picture here on the left, I love talking about this picture. This was actually my first week at NASA. So me and Megan actually have a very similar picture. We did not talk about this beforehand. So that's me as an intern on my first week at NASA. And that's me looking inside the vehicle assembly building. As you can see, it's huge in there. And actually, if you look behind me, that's what it looks like from the outside. Those are the largest doors in the entire world, and you can roll the Statue of Liberty right on it with room to spare. I love this photo because it not only does it represent this amazing structure, but it also represents me kind of looking out into infinite possibilities. It looks like you can fit infinite amount of things in this building. And it really just gives you this sense of wonder, which I really had on my first week. Fast forward to this next photo of me. This is about 5 years later. And this is me doing an outreach event very similar to today. I got to go to MegaCon in Orlando, where we were able to talk on a panel and answer questions from about 100 to 150 eager people that I got to talk about Artemis. And it's just an amazing little journey. If you look at these two pictures of my first week, where I knew nothing. I wasn't even sure I belonged there yet, to 5 years later, where I'm confidently talking about what I do and all the impact that I've been making to NASA and science and space exploration. I got an economics degree from the University of Central Florida. Another thing that me and Megan have in common, we both went to Central Florida, go Knights, and I have a sociology minor. Before NASA, I actually worked in retail for a long time. I was in retail management, general managers of different retail stores. I did that for about 8 years, and it wasn't until I was 26 years old that I even decided to not only get a college degree, but at the time, I didn't even have my high school degree. I actually dropped out of high school just due to lack of grades, lack of motivation. I wasn't a bad student. I just didn't do any homework in my entire senior year. So sorry for my parents having to deal with that. So I just kind of decided I want to take control of my life and have some accountability. So I went, took my GED test, got my high school diploma, and then I went on to college. And from there it was just this amazing momentum of working hard, getting good grades, and then seeing, okay, now that I have these good grades, now that I have this high school diploma, now I can do college. Oh, now I have my AA degree. Now what's the next step? And as you hit each milestone, you really start looking at the next milestone, and the things that felt so impossible end up not being that impossible as you get closer and closer. While I was in college, I actually worked in an Italian restaurant, and I worked in every position you could think of in that Italian restaurant, from the host to cooking the food, and that really inspired a huge hobby of mine, which is cooking and bread baking as well. I'm also work on my house in my spare time. I bought a house a few years ago, and I'm attending what I like to call the YouTube University. You can learn anything on YouTube, and I'm learning how to fix everything that breaks in my house as I go. And I love gaming, and I like to go to concerts. Little flex, I did go to the Taylor Swift Eras tour last year. It was super fun, and I love just kind of being in the stadiums and hearing the music. I also have some pictures down here. This is me and my wife at a theater in Nashville. My wife is a teacher. Another shout out to all the teachers out there. You all are really the heroes, really making this country improve and grow. And we couldn't be doing anything without you. So I really appreciate that. That's me making homemade pasta, and that is that's my little cat. And I am a proud cat dad, and he is amazing and obviously very photogenic. So that's a little bit about me, and I'm really excited to talk to you about the Artemis program. So Artemis, we've been saying it a bunch already. What is Artemis? So NASA has a new program. It is the Artemis program. It is the next huge program for NASA. When you think of NASA programs, you think of the Apollo program, the Gemini program before that, the shuttle program. And this is the next one, Artemis. We wanted to call it Artemis because Artemis is the twin sister of Apollo and the goddess of the moon in Greek mythology. And it's a great way to kind of connect to our past. Artemis is going back to the moon. And as the twin sister of Apollo, Apollo being the original space program of going to the moon back in the late 60s and early 70s. Now, when I say, and you're going to hear this phrase a lot, the Artemis generation, when we say that, I don't mean that it's just the people at NASA that are the Artemis generation. The Artemis generation is a collective effort by everybody in the country and really everybody in the world. The teachers who inspire, students to pursue jobs at NASA or somewhere in the science or aerospace industry. The students, all of you are the Artemis generation. When I say we're going to the moon, I mean that you and me are both going to the moon. We are doing this together with your support, your commitment to school. And there will be a time when you all will be where I am, talking to other people and explaining all the amazing stuff that you're doing for this program. Parents are part of this generation because without you supporting your kids and telling them they can do anything, I mean, that's equally as important. And especially like the tech companies and the commercial partners like SpaceX, they're part of this generation. The federal government supporting NASA, giving us funding, international partners like the European Space Agency and JAXA, which is the Japanese Space Agency. The Artemis generation is all of us working towards a common goal of sending humans back to the moon and beyond to Mars. We have a slogan, and you'll hear it in some videos, and it's "We are going." And that we is us at NASA and all of you. So why the moon? We have a great video that's going to explain why we want to go to the moon again.
We are going. The history of this agency is marked with broken barriers, once viewed as impossible, with science fiction turned reality, with innovations that have spun industries all their own, and with demonstrations of peace for all humankind.
We soar in the skies of our home planet. We maintain a human presence just outside of gravity, and we touch points all across the solar system and beyond. We're going back to the moon, and this is why.
The moon is a treasure trove of science.
It holds opportunities for us to make discoveries about our home planet, about our sun,
and about our solar system.
The wealth of knowledge to be gleaned from the moon will inspire a new generation of thought and action.
Without fail, every major program and mission NASA has invested in has led to technologies and capabilities that have shaped our culture.
The breakthroughs of the Artemis era will define our generation and the generations to follow.
The tens of thousands of jobs associated with propelling us to the moon today are just the beginning of a lunar economy that will see hundreds of thousands of new jobs develop around the world.
This is not an ambition of one entity or one country. The exploration of the moon is a shared effort,
woven together by a desire for the greater good.
Why the moon? Because the missions of tomorrow will be sparked by the accomplishments of the Artemis generation today.
Because the ambition to go has already begun.
and because Mars is calling. We need to learn what it takes to establish a community on another cosmic shore. So let's camp close before pushing out.
And so, we go to the moon now, not as a series of isolated missions, but to build a community on and around the moon capable of proving how to live on other worlds.
Man, I love those videos. Every single one just really drives the message home, and they're so well done, and those are made by people at NASA. So, I mean, that really explains why we're going, and so we need to get there. So we have a spacecraft, and this is how we're getting there. So we have what's called the SLS. NASA loves our acronyms. So I'm going to explain to you what the SLS is. The SLS is the Space Launch System. And this is going to be the rocket that brings our astronauts to the moon. The SLS is the only exploration class vehicle capable of sending humans into deep space. And there's no other rocket that NASA has ever built that has nearly the power or the capability that the SLS has. It's able to lift really heavy payloads all at once, so we actually have to do less launches in order to bring everything to the moon that we need. It stands 322 feet tall, and it weighs 7.75 million pounds. And it can lift, it has a thrust of 8.8 million pounds. And what's really amazing about it is it's designed for flexibility. Depending on what mission we need, we can adapt this space launch system to fit our needs, either by carrying a lot of payload, by doing a test mission, by putting astronauts on the top of it in our Orion capsule. So we really thought about the effectivity of this and what we can use this for. It's an absolutely incredible feat of engineering and science. I've been so up close to this thing, and it is absolutely incredible. So although this is what's going to carry the Orion capsule with the astronauts in it to the moon, we also have the Orion capsule itself. And that's going to be right here. Perfect. So the Orion capsule, this is the spacecraft that's built to take humans farther than they've ever gone before. Orion's going to serve as the exploration vehicle that's going to carry the crew to space, provide emergency abort capability, sustain the crew during space travel, and provide a safe re-entry from deep space as it splashes back down. It's absolutely an amazing feat of engineering. What's really great about the Orion capsule is it's designed to be able to accommodate about 99% of the human population. Not all at the same time. Obviously, we can't fit all 8 billion of us in it at the same time. What I mean by that is that even if you're not tall or really tall, or male or female, it's able to accommodate you if you're 4'10" or if you're 6'5". So it's a great way to make sure that regardless of your size, we can get the best astronauts for the job, and that's really great. It has this amazing heat shield on it. So when Orion comes back down into the atmosphere after it travels, it splashes down. But to get there, it has to go through Earth's atmosphere, and Earth's atmosphere will make it very hot as it comes down. But it's also the way that we slow down the Orion capsule enough. It's kind of like a natural braking system. But it's really hot, and so we have we have a way to keep the heat from hurting the actual spacecraft with the heat shield. It can keep up to 4,000 degrees Fahrenheit. It's absolutely incredible. And on its return speed, it'll actually be coming in faster than a bullet. Obviously before it slows down, because we don't want it splashing down at those speeds. Next, we have Joe Acaba in a video talking about the Artemis missions themselves, and all the incredible stuff that we're doing.
Hello, I am NASA astronaut Joseph Acaba, coming to you from the Johnson Space Center in Houston, Texas. I studied and worked hard, graduating high school in California and then earning both a bachelor's and master's degrees in geology. While working as an astronaut after my last flight, I earned a master's degree in education, an area I strongly believe in. Education opens doors to so many opportunities. Much of my life has revolved around education, both as a student and a teacher. My education got me to where I am today. When I became an astronaut, it was like going right back to school. We have to learn all about our spacecraft, we learn to speak Russian, and we train in high-speed, high-risk operational environments to help us get ready for a space mission. I've flown 3 missions, one aboard the Space Shuttle Discovery, and twice on the Russian Soyuz spacecraft. Missions lasted from 2 weeks up to 6 months. Here at NASA, we continue to advance the research and technology to return humans to the moon. We are still pushing forward with plans to send the first woman and first person of color to the moon under NASA's Artemis program. No human has set foot on the moon since Apollo 17 in 1972. So the possibility of landing on the moon is incredible. On November 16, we watched Artemis 1 launch and execute the first lunar orbit in more than 50 years. This was the first integrated flight test of NASA's Deep Space Exploration Systems, the Orion spacecraft, Space Launch System rocket, and the ground systems at Kennedy Space Center in Cape Canaveral all came together for this extraordinary mission. Artemis 1 traveled a total of 1.3 million miles to the moon and back. After a 25-day mission, Orion successfully splashed down on December 11th in the Pacific Ocean. The capsule is now back at Kennedy Space Center, where it is being tested and studied. Up next will be Artemis 2, taking astronauts to the moon, and it will be here before we know it. I'm currently the chief of the astronaut office, ensuring crew safety and mission success. My hopes are to inspire the next generation of explorers and leaders, and to help elevate, build awareness, and highlight the teaching profession and its importance to our society. As you learn more about NASA and all that we do, I want you to remember that we are all crew members aboard a space station, our beautiful planet Earth. Viewing the Earth from space reminds us that we all share the same orbiting sphere as we travel around the sun together.
And that's a great introduction to our Artemis program. So the first one he mentioned was Artemis 1. And Artemis 1 happened. Not only we would like to say we are going, but for this one, we went. We did go. Although there was no crew aboard this mission, it was important to make sure that our integrated system works. Everything that we tested worked how we thought it was going to, and to make sure that what we thought was possible, and it's possible. This launch, I was about 3 miles away from this launch, the safest you could possibly be. I was there. It was at about 1:47 a.m. At Kennedy Space Center, and it was absolutely the highlight of my career so far. I've been with EGS for about 5 years or 6 years now, but at the time it would have been about 5 years. And up until this point, everything that we saw was either a diagram or a simulation or a chart on a screen or words on a page. And although NASA can test and test and test and simulate and guess, seeing everything that at first was on paper or on a computer actually happen in front of us and know that we were a part of it, and you know, this mission would have not happened without all of the hard work that everybody that I work with put into it, and everybody who worked on the SLS and the Orion. It was just an incredible night. And we all went to work the next day ready to work harder than we've ever worked, because now we knew what was possible if we just put everything into what we were trying to do. So once the Orion capsule separated from the SLS rocket, it actually was able to go to the moon. And so once it was there, we decided we'll take a selfie. Why not? So this is our Orion taking a selfie of itself. It's connected to one of the solar arrays to get a nice to get some nice distance. They're very similar to us doing this, you know, and taking the picture. That's what Orion was doing, and there's the moon behind it. This happened on December 5th, 2022. It was on the 20th day of the Artemis 1 mission. And it's just so incredible that this photo is it's real. We really went there, and you know, you can see that the detail of the moon, and it just gets us so excited to see as we get closer and as we start landing humans on the moon, just what we're going to get in terms of what we can study and what we can learn with today's technology. Because keep in mind, we haven't been back there in over 50 years. So this is just a fun little photo that we always love to share. So on its return back, like we mentioned earlier, it splashed down in the Pacific Ocean on December 11th. And this was also a huge test for us because keep in mind, we will have astronauts in this capsule on the next mission. So we wanted to make sure that everything worked and planned as we wanted to, that we were able to successfully land and recover that capsule, and anybody on board would be safe. So this was recovered by NASA's landing and recovery team, along with the help with the U.S. Navy and the Department of Defense, and we were on board the USS Portland. So this was another huge milestone for the Artemis 1 mission. So that's what's happened behind us, and now we have a lot of exciting stuff ahead of us. So Artemis 2 is scheduled to launch in September of 2025, and it will be the first Artemis mission with crew on board. It's going to bring astronauts further than humans have ever gone from Earth before. It's going to be a 4-person crew. It's going to test to make sure that the crew is going to be familiar with the capsule. It's going to test all of the human stuff that we couldn't test on the first one. The first one we wanted to make sure that the humans would be safe, and now we're going to make sure that everything in there is going to work as we expect it to go, which is going to lead into our third Artemis mission where we will land people on the moon. But before we get to that, I really want to introduce the crew themselves that were selected for this historic mission.
When I was young, I had a poster of the Earthrise picture, the famous picture that was taken on Apollo 8. And the fact that it was a human behind the lens that made that picture so profound and changed how we all thought of our own home was so amazing to me. The moon is not just a symbol of thinking about our place in the universe. It's not just a symbol of exploration. It's actually a beacon for science. It's a beacon for understanding where we came from.
You know, pushing ourselves to explore is just core to who we are. It's a part of being a human. That's our nature. We go out there and we explore to learn about where we are, why we are, understanding the big questions about our place in the universe. The exploration we're doing is the first few steps on the path of getting humans to Mars.
The Artemis campaign of missions have set such an ambitious goal for humanity that it's inspiring contributions from around the globe. Not just one nation is inspired and moved by this, but nations from around the globe are coming together.
When I look at the Artemis 2 crew with Victor, Christina, and Jeremy, they want to go do this mission. They are keenly driven. They are humble to a fault. It is so cool to be around them. Artemis 2 is a huge mission, but I hope we will look back and realize that this was one tiny step in humans on Mars and a sustained presence on our moon.
Before the start.
Artemis 2 will be NASA's first crewed flight test of the Space Launch System rocket and Orion spacecraft around the moon.
To verify today's capabilities for humans to explore deep space
and pave the way for NASA's long-term human and scientific presence on the lunar surface.
We are ready.
We are going to the moon for all humanity. We are Artemis.
So there's our Artemis 2 crew, such amazing individuals, and their point of view of what Artemis is just so inspiring. you know, when I see this crew and I think about what we're doing, you know, I wasn't alive during the Apollo missions, and so I wasn't able to see the first person walk on the moon. So I read it in history books, and although that's great, of course, you know, I wasn't there and I don't have a memory. I have a you know, a page in a history book to learn it, and although I have the, you know, the names memorized of Neil Armstrong, Buzz Aldrin, and Mike Collins as they made history landing on the moon, you know, I know that this time around, myself and all of you are going to not read these missions in history books. You're going to be able to experience it and see it live. And these names are going to be in a history book one day. And you're going to be teaching your kids or your grandkids about these things. And you're going to be able to say, I saw it and I was a part of it. Even if all you do is see it from a live stream. So I definitely suggest all of you do what you can to be able to see these launches when they happen. It's so exciting. I also like to say that when we work on everything that we work on and we develop all of the machines and all the facilities and all of the safety protocol that we go into to make sure that our crew is able to get home safely, I always think about who I'm actually working for. Sure, I have a lead and I have a supervisor, and I mean, you can go all the way up the chain of NASA, but really all of us are working for these 4 people, and they're depending on us to make sure that the mission is a success. It's just super inspiring, and it's really motivating to for me at least, to try my hardest every single day. It's amazing. So that's Artemis 2. Moving on to Artemis 3. You know, I mentioned the first time we landed on the moon back in the 60s, and this is going to be the next time that we land on the moon in over 50 years. Artemis 3, a year after Artemis 2, we will have not only people landing on the moon again, but we will have the first woman and the first person of color land on the moon for the first time. And that's really, really important to us, to me, to NASA. You know, I know in that video with the Artemis 2 crew, Christina mentioned how she saw the Earthrise over the moon, and a person did that. And at that time, it was just about anybody being able to do it. It was a humanity goal, and that inspired her. Can you imagine if it was a woman who landed on the moon, and how many girls out there would say, I can do this. I see them doing it, and I can do it. And so that's just so important, that not only do we inspire students across the globe to want to work here, but we want to make sure that everybody can look at somebody who is accomplishing things and say, I look like them. If they can do it, I can too. It's one of our biggest goals, is to constantly inspire everybody to work hard and be here. We are going to land on the moon. We're going to be on the moon for 6.5 days. It's going to be, you know, we call it a moonwalk. Maybe they'll do a moonwalk on the moon, maybe not. And what's great about this mission as well is that we'll also be using our commercial partners. So not only will NASA be bringing the crew, but SpaceX and Blue Origin will be sending what's called our human landing system up there early. So we're really connected to the commercial partners, and we work really well together, and we do stuff, they do stuff, we learn from each other. And so it's really great to see not only NASA being involved in this, but sharing a goal with all of the aerospace industry on this common mission, this common goal of getting people back to the moon. So once we land on the moon, we did it. What's next, right? So far, it's been the same as the Apollo. We sent people, we brought them back, but that's not all we want to do. Artemis 4 is going to be the real beginning of staying on the moon and building sustainable science to keep people there and study for longer than a 20-day mission. And we're going to do that by building what we are calling Gateway. Gateway is going to be a space station that is going to go around the moon, similar to the International Space Station that we have now that goes around Earth. It's going to allow us a lot of flexibility in our missions. It's going to allow us to collect samples and bring them up and do some tests while staying on the moon, which is a lot easier than bringing the samples back to the labs here. Why don't we just bring the labs to the moon? And Artemis 4, which will actually be a larger, more powerful rocket than the current SLS configuration, which we call Block block 1. This will be called block 1B. It's going to be able to lift and carry even more, because if we have to build this, we have to bring it, and then the least emissions as possible to build this thing. So we need extremely powerful rockets to do it. We are working on all 3 of these missions right now, Artemis 2, 3, and 4. I am in meetings with conversations about about all of these right now. These are all real, and we're really excited to see these happen. So that's kind of the short-term plans for Artemis. Now I really want to kind of switch gears and talk about you all and how you guys could contribute to all the amazing stuff that we're doing.
We need you, all of you, to go for everyone.
Where no one has gone before, to help humanity reach our collective goals of exploration and discovery.
Unlock your potential side by side, interns, civil servants, and contractors.
You will be mentored, you will be coached, and you will be challenged for your personal growth and for the success of the Artemis mission.
Your talents,
your skills,
and your perspectives are needed to make this possible.
Splashdown.
Begin your journey from the ground up. The time is here.
The time is now.
That's another amazing video, and it's so true. The time is now. It really is. These are some of the different types of the types of roles and responsibilities and jobs that we have out here in NASA. This is a very, very, very tiny sample of all the things we do out here. As you can see, all of these roles involve the STEM degree. Science, technology, engineering, and math. If you pursue any of those types of degrees, you can do any of these types of roles. Everything from software developing to being a launch engineer, being in the firing room when we launch. You can be a CAD designer. If you have an artistic talent, you want to design things in a computer that we eventually turn into real designs and then real rockets. We have a place for you here. Project manager, maybe you're better at just kind of seeing everything from a high level and making sure that everything goes smoothly and tracking a lot of different things. You can be a project manager, and you can, NASA's really supports cross training and cross learning. So you might start as one thing and end up as something else. And getting a STEM degree is an amazing start to doing that. But not everybody out at NASA has a STEM degree. And some of the greatest ideas come out of the ones that don't. Not that I'm biased, I don't have a STEM degree, and I think I'm doing pretty well. But we do have a lot of jobs. If you think of anything that goes into running a company, we have something similar here at NASA. So we have social media. We want to have a strong social media presence to make sure that we reach as many people as possible and make sure that everyone knows the right path to work here, as well as just know what we're doing. We have graphic designers, robotics designers, geologists. If you like weather, if you can think of any of your passions, I promise you that there is a spot here for you, and we will use your skill and what you're passionate in and find value in that towards our mission. I also want to, I think it was mentioned before, but NASA loves teachers. Teachers have always worked out really well. And I know if teachers out there, you might think, oh, a teaching degree or an education degree only offers me to be a teacher. And that could not be further from the truth. The skills that you have lend so much to what we do, and NASA loves hiring teachers, and they always work out very, very well. So here's a few people that are Virgin Islanders, and they are working with us. We have Dr. King, senior researcher at Langley Research Center, graduate of Ivana Dora Keene High School, class of 1983, and Simone Fullwood, a senior systems engineer raised in St. Thomas and attended the Adelita Cancreen Junior High School. And it's just so amazing that we have a workforce that comes from anywhere, and it's such a great way to show that no matter where you are and no matter what you're doing, you can work here. And I'm almost certain that they got here from just working hard, believing in themselves, taking a risk on themselves, trying new things, challenging themselves. And sometimes, I'm not saying they did this, but I'm saying sometimes you're going to try something and fail, and you're going to learn from it. I'm sure they were not afraid of failure. And it takes a lot of grit to get here. And I have to be honest that one of the biggest lessons that I learned while starting here was that, exploration, like it says, exploration is a team sport. I think learning how to work on a team and be a team player, I know it sounds cliche, but it is one of the biggest and most important skills you can have. You might be the smartest person in a room, but if you can't work on a team, and if you can't bring a team together, or if you're not fun to work with, or if you're miserable to work with, it doesn't matter how smart you are. It doesn't matter what idea you have. We need to work together. If we have a problem, one smart brain is great to solve a problem. 20 is even better. 100's even better, because you never know when the idea is going to come from left field. And I can give you a million examples where a suggestion is thrown out in a meeting when we're working on a really hard problem, and it might even been a half joke, and somebody goes, actually, you know what? That might be what we need to do. And it's just incredible. Being a team player, being easy to work with, and being likable by your coworkers is an amazing skill to have. And I would say being able to communicate as well. It's something that I've also struggled with that I learned very quickly is I need to make sure that I can express the problems that I have clearly. I can express solutions to problems that I have clearly. If I have an idea, I need to make sure I can communicate that idea in an easy to understand way. So if you're asking about what skills or what things could I have going forward to make my success more possible at NASA, I would say make sure you're a great team player and make sure that you know how to communicate effectively. I know those aren't the things that you thought I would say, but those are definitely them. And those are the things that a lot of people learn along the way. And if you're great at those out the gate, you'll find success even faster here. So that's the presentation, and I'm happy to take questions. Christina, take it away.
Okay, so I'm just going to use that as a jumping off. One of the questions that came in is, if you are a high school student, how can you prepare yourself now for the NASA intern pathway that would then lead to a career pathway?
I think Megan has a great answer. I'm going to say out the gate, do your homework. From experience, do your homework, and don't give up, and finish high school on time, and make your parents proud. I know some of you are rolling your eyes and I don't want to do my homework. Just do it. Learn how to do it. Learn how to do things that you don't want to do, because you're going to
your future self will thank you.
Your future self will thank you. Absolutely. Yeah. Megan, if you want to answer this as well.
Yeah. I think, there's no time too early to start preparing if you see yourself working at NASA one day. I think number one is to just say, okay, what are my interests? What are the things that I might like to do at a job in general? And then you can see where that could land within NASA. If you're in the very beginning of building your resume and connecting with people and just making sure that you are diversifying yourself, volunteering, doing things like that really give you different life experiences that will set you apart from somebody maybe next to you. So I would say just think about those things and what makes you unique. Work on your public speaking abilities, work on your interview skills with people that you know, do mock interviews, do all of those sorts of things, because all of that is just going to do nothing but help you in the future. But I know Christina has a couple things for some of the Virgin Islanders that may be good opportunities, if you want to talk about those.
Sure. So UVI has just launched a new program, the UVI NASA Pre-Engineering Program. It's a summer program where you get to live on campus, dine in the cafeteria, do all of the things. It's like having an opportunity to experience college while you're still in high school. The applications will be coming out in the next week or so. I'll send them to your teachers. There are 3 things that you need. 4. 1, your application needs to be submitted on time. If it's not, we can't accept it. There's only 20 slots, 10 for St. Croix and 10 for St. Thomas St. John District. So it's a very small group of individuals because it's a pilot program, but it is something that we offer. The application will require a 2-minute video, 1 to 2 minute video of you and an essay explaining your interest in STEM. Your video will focus on why you want to come to the program and stay in the summer. It will be in the last week and it's really fun. We do hands-on activities. You'll get guest speakers. You'll be all over campus, and we do NASA movie nights, Hidden Figures, The Martian, lots of really, I think it's called A Million Miles. The farm worker from Fresno who I think he applied like 10 times, and then on his last try he actually became an astronaut. So lots of really cool things. And for those of you who watch Joe Acaba, while he's from Southern California, he actually has roots in Puerto Rico. So it doesn't matter who you are. If someone from Puerto Rico can make it to the moon, the Virgin Islands people can make it to the moon. So failure is my favorite F word. Go out and fail, because if you don't fail, you don't succeed. Try and see what you can do. Also want to tell you, UVI has an observatory. A lot of our interns take time and work up at the observatory, and on April 8th of this year, it will be the eclipse, and I put in the chat. And for the teachers, I'll send out the link for the NASA map. And this year, fortunately for us, it's on the eastern side of the United States. So we will actually get to see approximately 50% of that. As we close out, I want to go to Hunter. Hunter, any closing comments for our audience before we go?
Yeah, thank you for saying all of that. I just want to remind everybody that, 6 years ago, 7 years ago, I didn't think NASA was possible at all. And I think almost everybody out here has some original story that landed them here. Not everybody does the perfect textbook career path. And sometimes we have to take some detours and come back, and those detours are what really shape us. And it isn't so much about where you start, it's about where you end and the journey that you take to get there. And NASA knows that. They don't look just at where you are, but they look at what you did to get there. So, like Christina said, take risks on yourself. Say yes to things that you might not think are interesting. I said yes to an economics course that I didn't know what economics actually even was when I was saying yes to a course my first semester of college, and it just clicked with me, and the rest was history. So I challenge all of you to challenge yourselves and do your homework. Thanks for having me, guys. It's been amazing. I love talking about the Artemis program.
Megan?
Yeah, I mean, I want to just piggyback on what Hunter is saying as well. I think, I very similarly did not see myself going into the communications field, which is what I have built my career in. I was a painfully shy child, extremely introverted. When I first told my parents that I was going for a communications degree, they literally laughed, because they were like, you who doesn't like to talk in public or do all of those things. So I think it's something that it's like, you might not know exactly where you're headed, but trying those new things that's how you discover that. So, like Hunter said, he took an economics course, not really knowing what that is, and then found a passion in it. I similarly with communications and then education. And I think if I can provide one piece of advice to just all of the students who are starting their careers, just keep going. You will fill out dozens, if not hundreds, of applications for jobs and internships and all of that over your career. And it is a numbers game. Put your information out there and eventually the right thing will come to you. And every no that you get eventually turns into a yes. And, your story is your story. And one day you'll look back at this time in your life and be like, wow, that's so fun. I didn't even know that was ahead of me. So I think just try hard, do your homework, and thank your teachers for everything that they do, because they are the ones who are, it's on their shoulders that we are all succeeding. And I think that it's so important. And we appreciate all of your time. And I hope that one day we'll work alongside some of you, if not all of you.
Thank you. My closing comments to our future scientists and students across the Virgin Islands, the nation, and the international community watching across the globe is just choose your heart. Hunter gave you an excellent example of, you know, making a decision, and it was the harder decision, but when he committed, right, he sailed through it because it was what he wanted to do. And where you start isn't where you're going to end. So again, take the risk, go out and take something. And if you don't like it and you fail, it's not the end of the world. Everyone has failed at something in their life, and that failure gets you one step closer to your goal. And if you look at the NASA program and the launch to the moon, when they were designing that initial rocket, they failed and they failed and they failed. And it took the brilliance of the key person in Hidden Figures, Katherine Johnson, to figure out the math behind this science. So girls in science, minorities in science, everybody in science, let's just kind of like reach for the stars, shoot for the moon, and let's all try to work for NASA or beyond. Thank you for taking the time to share your afternoon with us. Wherever you are, St. Thomas, St. John, St. Croix, good afternoon, and we'll see you next year. Thank you. Have a good weekend, everybody.